For a hobby supply there must always be a kind of shortcut protection, and there are many ways to realize that. When we are talking about, say, the more modern voltage supplies, we see often all kinds of circuits, say a triac, or in another way, say a back coupling unit that is used to, say, in a certain way rein the input voltage and output voltage, and there are many possibilities, but I only focus in all my videos about back coupling circuits that are in a certain way directly related to Ohm's law, and then I mean that I use, for instance, a high resistance here at the output of a power supply. And well, in general I use, for instance, some car lamps, automotive lamps, or 50 watt or perhaps 20 watt, and I mount them in series with the load, so in series with the output voltage, and that goes very good when we are talking about voltage supplies in the order that deliver voltages and currents in the order of, say, 20 volts up to 30 volts. And when you go to the World Wide Web, you will often see power supplies that are made for voltages in the order of 0 up to 35 volts. But there is a kind of problem with all these power supplies. The first problem is that they are, say, in a certain way always rain or set the output voltage via complicated circuits like comparator circuits, etc. And my focus is not on all these, say, in a certain way difficult voltage supplies, but only, say, simple voltage supplies and linear voltage supplies. And when you know a little bit about linear voltage supplies, you will surely know that they are in a certain way not ideal, because their efficiency is low. You can lose a lot of heat inside here, say here in this case, in, say, the end transistor that drives the output voltage. So now it's shortcut at the moment. I've shortcut this power supply by purpose to look what it can bring, and etc. Will the transformer burn out? I don't know. Will the primary fuse that's here burn out? I don't know. Will the secondary fuse here, it's 2.5 ampere, burn out? I don't know. Will the transformer so hot, it's very hot at the moment by the way, that it will destruct itself? I don't know. So many things that I don't know, but on the other hand, when you are a hobbyist and work with such a power supply, be it from Ali or from whatever source, you must be sure that this such a power supply can handle a lot of overload. And not, that's my idea, not switching off when, say, the parameters go too high, especially the output current gets too high. Anyway, so transformer is hot here, I know it. The fuse is not popped out. The current is at the moment with a shortcut 800 milliampere. I'm more or less sure. I want to refer to my earlier video. What does my other meter tell? Yes, it is 12 ampere, 1 ampere. Well, this meter shows a current in the order of 400 milliampere. Anyway, my meter shows 800 milliampere, and of course this is perhaps not a properly aligned DC current meter. I want to refer to the earlier video. Now I've used not a simple carbon resistor of 10 ohms, but here, wow, they are very hot. 3 power resistors of 3.3 ohms in a row, so they can handle the current. I'm absolutely sure. And also something to talk about, to be aware of, that even such a shunt resistor that has the aim of making here such a microampere meter work, also has an effect on the output current. And of course I know, because I've shortcut the whole the power supply, that more or less everything this is dissipated here in the shunt resistor that bridges the DC ampere meter. And well, I'm more or less sure to believe that now 800 milliampere is flowing, etc., etc. So this will be kind of long-term test. The 2 and 3055 does not get warm or hot. The chip that has to do the job, the 317, also does not get warm or hot. Only the shunt resistor is now, say, the resistor that picks up all the energy sent out by the transformer. So, transformer, does it get hot? Yes, surely, it's hot. The core is hot, that's what I mean. And when we are talking about transformers, why do cores get hot? Because there's loss in the coil, so energy is dissipated in the core. In this case, laminated steel. Could be that after, say, a certain moment, this transformer will burn out. Of course, that's not my aim. Surely not. But could happen. And well, and there is in a certain way, there are always in a certain way talks about safe values. So can this power supply endure a constant shortcut? Yes, it can, but of course only say for a certain time. Could be in this case 1 hour, 2 hours, 3 hours, 5 hours, I don't know that, perhaps even 24 hours, but that is also one of the aims of the power supplies that I want to make. So now we have 800 milliampere. It's all going into, dissipated into these 3 power resistors. Each of them is 3.3 ohms, so together they are 10 ohms. So is this a complete shortcut? Of course not, but anyway, I need these 3 resistors to bridge my amperemeter, to make it suitable for this aim, say indicating currents between 10 milliampere and 1 ampere. So anyway, thanks for watching. Ohm's law is valid, and this is only, say, a second vlog. Pen over somewhat. Does the N transistor get warm? Well, a little bit warm. The transformer gets hot. Anyway. So, thanks for watching.